In our last session, we extended our Java text editor to allow it to open files. So we added a few extra classes, namely the IO Manager class and a controller class, and we added the JFile chooser as well for the user to browse for files in the file system. This functionality works just fine so far, so we'll be able to set, say for instance, open up a particular text file like this and display it in our editor. In this particular session, we'll be adding the functionality to allow our editor to write files out. So our editor may optionally, or at least our editor may allow the user to either save existing files that have been previously opened with the existing changes, or create entirely new files and save them to the file system. So as an example, this is a simple text document that I've prepared. I can make a simple change here, put some more text at the top for instance, and then I can hit save, and that will immediately write out to the file system the new changes, or at least the changes that I've added to the existing document. You'll also notice that as I open files, the name of the particular tab is altered to reflect the file. Likewise, if I choose to start a new document, let's say that this is a new document, the default name appears here until I choose to save it. Now in this particular case, the system already knows, it should know, that it's not an existing file from the file system, but it's a fresh file that hasn't been saved previously, so this state needs to be maintained. And in this particular condition, our Java text editor should prompt us to save it to the file system. So this is where it suggests, where to save it. So we can choose to give it a name, my text file 1.txt, for instance, and we can choose to save it. Now immediately you'll notice that as we save it to the file system under a specified name, the tab changes dynamically, and this is the functionality that we want to build in this particular session. To get this done, we'll need to add a couple, not really a couple, a few extra methods in our UI class and in our controller class and in our IO Manager class. Namely, we need a new method to handle the SaveTextDocument behavior, and this will be thrown inside of our controller class. We also need a new method to activate the SaveFileDialog. Remember, this is the other mode of our JFile chooser that allows them to save to a particular location as opposed to opening an existing file from a location. We'll also need to access the specific text documents within the specific tabs, because we have a multi-tabbed editor in this case. So we'll need a method to efficiently and conveniently grab the particular text area, or at least the active text editor area that has been selected, so that we can in turn look inside of it and grab the text document within it and grab its contents and save it. Grab its contents and say, for instance, reflect that in the tab, for instance. Alright, so we'll add these methods along with some others. We'll also need a method to dynamically change the name of our tab as a new file is saved. So we'll make these changes in a bit. So what you want to do is immediately go to your IO Manager class, and we'll pick up where we left off from the last time. So right now we're going to build into our IO Manager class the functionality to save documents, or write text documents to the file system given a file reference. As you can recall from the last session, we created a method to read text files from the file system given a file reference. We're going to create the counterpart here to write. So this particular method will save data to a file based on a specified path as prescribed by the file reference. So we'll call our method writeTextFile, and we need to give it some arguments. The first of which are the first of which is a file reference. As a matter of fact, this is the main thing that will represent the file that should be written to the file system. Secondly, we'll need to give it the data that needs to be written out to the file itself based on that file reference. So it needs two arguments in that case. Then we also need to set this up so that it throws an exception, simply because we don't want to be catching and handling and reporting in this particular class, because it's a very specialized class. We'll do that later on in the application. So it will throw the exception just like the previous counterpart method threw the exception. So it can be handled elsewhere. In this particular case, we're going to use a buffered writer, a high-level stream, to do the writing to the file. As you can recall, we still have to deal with a char array, since this will eventually have to get to a low-level stream in that sense. So we'll set up a char array, call it chars out, and we'll take the file data, which represents the string, the holistic, or at least the unified string of information, of text information that needs to be written out. And we're going to call it the toChar array, which will break that string up into individual characters and save it as a char array. Next, we'll set up our buffered stream. We'll call it buffout. In this case, it was already declared up top. And we're using, again, like I mentioned, the buffered writer stream. And this is a high-level stream that wraps around a low-level stream, which is the file writer in this case. And we'll pass to the file writer the file reference indicated by f, the variable f. Now, as you can imagine, the file writer will link to the file reference, which is the destination itself that should exist on the file system already, may exist in the file system already. If it doesn't exist, as these streams begin to write, it will automatically generate that file on the file system for you. So once these streams are set up, the next thing that we need to do is tell it to write. So we call the buffered outputs write method, and we can specify, in this case we're using the offset and the length, but you can leave these out if you wish, and just supply just the chars out array. So this particular line will write all of the contents that we supply to the method in the form of file data broken up into chars out, for instance. We'll write all of those contents to the file system as indicated by the file reference f. Once that line is complete, then we'd like to ensure that we close our stream, so we double check to see if buffered output is not null, which means that the stream has actually been created. And then we flush it. Remember, I mentioned that buffered streams need to be flushed, forcibly flushed, just to ensure that all of the data is written out to the file. And finally, we close the stream itself. Okay? And this does it for the modifications in the IO Manager class. Next, we'll move over to the UI class, and we'll make our modifications down below. One of the first things that we'll do in a UI class is to set up the other mode of our JFileChooser, which allows the users to find a location to save a new file rather than open a file, browse for and open a file. So we're going to go just after our showOpenDialog method, and we're going to create its counterpart. Oops. We're going to create its counterpart named showSaveFileDialog itself. So we have these two particular methods which will eventually be triggered by the controller when necessary. So this particular method will display the save mode of our JFileChooser as opposed to the browse mode of our JFileChooser that we previously set up under the showOpenFileDialog method. So as you can recall, the file chooser, when interacted with, returns integer values to represent different options So for instance, if the user clicks on, if it's the open mode, if the user clicks on the open button, there's a particular integer value that represents the open button click. Likewise, if the user clicks on the cancel button, there's a particular different integer value that's returned. And this is the way that the file chooser is able to indicate to us as programmers which option the user has actually chosen while interacting with the file dialog. In this particular case, we're doing the same thing that we did before. We're setting up a variable named option, which is an integer, to receive the return value so that we can interpret what option the user has chosen through the JFileChooser. In this case, we're looking at a couple of options, but we're most likely interested in the approve option, which in this particular mode will be the save button click. Okay? So if the user makes the choice to save, then we'd like to get the particular file. Now in this particular case, that file would really be what the user has actually entered into, or at least, yeah, basically entered into, if it's a new file, entered the name into the particular field that's provided in the JFileChooser. Or if it's an existing file, it's the same thing. The name is already saved there, and the location is already presented. So the JFileChooser puts that together and returns a particular file reference to represent the file that is to be created, or the file that is existing, which should be overwritten on the file system. Otherwise, if the user chooses, to just forget about it and click cancel, then we just return nothing. So this is one of our first modifications, the save file dialog. Keep in mind that the distinction between the two methods is this particular method called on the JFileChooser. So it's the same JFileChooser reference that we used above, but in this particular case here, we're calling showSaveDialog to show the save mode of this JFileChooser, whereas in the previous implementation, we call the showOpenDialog method. So it has various modes of operation. As you can see here in our application, you'll notice that if we open a file, if we choose to open a file, there is no field for the user to enter the name of the file. Whereas if we choose to save the file, let me try to create a new file. If we choose to save this file, you'll notice that there is a field that prompts for the name of the particular file, as well as allows you to browse to the particular destination in the file system to save that file. So these two methods bring up two slightly different variations of the JFileChooser based on the context of use. Okay. So the next modification that we'll make is that simple utility method that allows us to dynamically change the name of the file of the tab in our multi-tab system when a file is saved under a new name other than Untitled.txt. And it's a very simple method called, and we're going to call our method setActiveTabTitle. We need to make our methods names as descriptive as possible. So what can get more descriptive than this? So this particular method will take an argument, a single argument, which will be the new title that will be set. This title would obviously be the name that you have chosen as an end user for the particular file that is that was just saved to the file system. There are a few things that this method needs to do. It needs to actually interact with the tab pane because it's the actual label on the tab pane that we're changing. So we're going to call it setTitleAt method, which, as the name suggests, sets a particular title at a particular tab based on a tab index. Now the way that we get the tab index itself is to identify which tab is active. Alright, so we call the tab pane once again, but in this case we're going to call it getSelectedIndex method, which returns the active tab index. So once we combine these two, we're able to set the title at the active tab index, or set the title at the selected index in this particular case. But where's the title? We need to also supply to this method the title that we'd like to set, and that's the second argument here. So as you can imagine, when the title comes into this method, it will be reflected in the selected tab at that particular index. Very simple method. So next we're going to move on to another utility method, which will basically allow us to interact with our multi-tab system and allow us to grab the particular tab component that we need to interact with in order to get the respective text document out of. And based on that, we'll be able to save the right contents based on the tab that we're looking at. So this method, we're going to call it getSelectedTextArea. All right, and it's going to return our custom class text editor area. As you recall, the text editor area is our custom text area, JTextArea rather, let's say extension. It's really a JTextArea that we've modified just slightly, and it represents that editable component, the component that the user interacts with to type and to view the text. Our text area, in addition to doing that, keeps within it the text document class, or rather the text document instance that represents the content and the file itself that is currently being displayed in the text area itself. So by just allowing us to access the respective text area that is active, in this case the selected one, we're able to get the actual document that the user is looking at. And this is what this method is really designed to do. So what we need to do, the first thing that we need to do is to grab, we have to go through layers. For instance, we have to grab the entire component at first behind the selected tab. So the first component down within the tab pane itself, as you can recall, is the JScroll pane, which is why we need to set up a simple temp variable, call it scroll pane, and set it up to receive the JScroll pane. The way that we do that is we call the tab pane's getSelectedComponent method. All right, and we know that we're going to have to receive a scroll pane because that's the top level component within our tab pane. That's the first layer. Okay. Once we get our scroll pane itself, we have to open up the scroll pane and peel it away to get our text editor area, because as we know, the scroll pane wraps the text editor area, and then we actually add the scroll pane, not the text editor area, to the tab pane itself. So the next line that we're adding to our method here actually opens up the text there, rather opens up the scroll pane itself and grabs it. So the way we do that is we call the getViewPort method on our scroll pane instance. It's a bit technical in this level. So the scroll pane itself, if you think about it, has layers of its own. The first layer in the scroll pane itself is that viewport, and we need to peel that viewport away to get the view. As you can see, the methods are chaining here. So we call our getViewPort first, and then we call the getView after we get the viewport itself. And that will actually give us the component within the scroll pane, which is our text editor area. The last thing that we do in this line is that we cast it, because it returns a generic object. So we need to cast it back to the object that we expect. In this case, it's the text editor area. And we receive into our variable over here the actual text editor area instance of the selected tab pane itself. Okay? And after this, we just return it. So just to go through that again, the method that we've just composed here will identify the currently active tab in order to return to us the text editor area that is currently viewed by the user. Now we'll need this later on in order to determine whether the user wishes to apply the save or new or open or whatnot operations on a particular document. But in order to understand which document within the multi-tab system that we should apply the save operation to, we need a method like this to identify which document is currently being viewed or which document is currently active within the user's multi-tab system in order to apply the correct or apply the operation to the correct document. Okay, so once we have these methods in place, we need to then move over to our controller, and we need to pull all of those methods together, coordinate them. So as you can recall, we modified our IO manager. We added a write method. We modified our UI class. We added a couple of methods in there, the first of which is to show a save dialog. Another utility method was to set the particular title at a particular tab, the active tab. And yet another method is to get the active text document that the user is looking at. So we're going to coordinate these methods in the controller class here. So move over to your JavaTextEditor controller class, and just after your handleOpenTextDocument method, you're going to create the handleSaveTextDocument method, which will contain the code to coordinate the saving of our text document. Now it's important to understand that saving has two possible scenarios in this case. The first of which, as you saw earlier, is if I had, let's say in this particular case, if I had opened an existing text document from my file system and modified it and hit save. As you notice, it doesn't prompt me to save it in another location under another name. It just goes right ahead and saves all of my changes directly to the file system, and this is typically how editors work. Whereas if I create a new document and I modify it and I hit save, it understands that that document does not exist in the file system. As a result, I must show to the user or prompt the user for in the name of the document, first of which, as well as the location under which I should save this document. So there are two scenarios that we need to consider while writing out our handleSaveTextDocument operation. So let's begin with the simple stuff. We at least need a file reference in this case, because either way we'll be dealing with a file reference that will pass to our IO manager for the write operation. So we'll declare a simple temp variable called f, which represents our file reference. First thing that we do is to grab the ActiveTextArea component, and this is where our utility method comes in, and we can access it through the UI reference that the controller has, and we call our newly created getSelectedTextArea method, which returns to us the ActiveTextArea component, which is of type TextEditorArea, to us, so that we can look inside of it and grab the text document from it. Alright? So that's what we do basically. That's the next step. So we look inside of our text editor area that we grabbed from our current tab, and we grab its text document by calling the getTextDocument method. Okay? And that's going to be saved in doc. Now once we have our text document, it represents the current contents of our, or at least we hope that it represents the current contents of our text area based on the user input or changes or whatnot. Okay. The next thing that we do is we consider the two possible scenarios that I discussed earlier, whether it's an existing file from the file system that is just modified, or whether it's a brand new file that is now being authored that needs to be saved to the file system that doesn't exist there yet. And the way that we can do that is by looking inside of the document and calling its getFileRef method. Now, you may recall that the getFileRef will return the file reference in the text document object itself. Now the file reference will only be there if that text document is initialized by an actual file that exists on the file system. New files, however, do not have this. It remains null in a new file because obviously it doesn't exist in the file system as yet. It just exists in the editor under the name Untitled.txt. So this is how we can distinguish between a file that is opened and modified and a file that is brand new and authored and not yet saved. So this particular if statement calls into the getFileRef method, and if it's null, that means it's a brand new file that's not existing on the file system. So then we go into the other condition and we fulfill that. We show the SaveFileDialog in this particular case. All right. So we call our UI's showSaveFileDialog method, and that should return, if the user goes through with it, a file reference. Now this file reference represents the name that the user wants to save the file under, as well as the location the user wants to save the file under. It does not represent the file itself, because we haven't actually written anything out as yet. It just grabs the information from the user through that dialog so that we can prepare it to be written out under that location and name. And that's what F represents in this case. Now, if we're dealing with the other scenario whereby it's a file that's modified, opened existing on the file system and modified, then we'll do something slightly different. We wouldn't show the dialog, of course, but we need its own file reference. We need to understand where this file is coming from so that we can actually save it there, right there under the same name itself. All right? So we call on the doc instance, which represents everything inside of that particular tab, the contents as well as the file itself. We call its getFileRef method, which returns the actual reference, and that reference will contain information about where this file was opened from and what name it was actually given originally before we opened it. Okay? Once we have that information, then we can consult with our I/O manager. And as you can notice, these conditions here, okay, seek to only initialize the file reference F, okay, and we can skip out of this if else statement altogether, because at this point we know that it's going to be a file reference whether it exists or it doesn't. It's going to be prepped and ready for us to proceed with this method. Now here we double check to see if it's null or not, because you know that the user may cancel, they may choose not to save the file altogether, and that may return a null value. So we don't want to go ahead with a null value because that'll crash our program. So we double check to make sure that it's not null. And if it's not null, we proceed with our I/O manager and writing out of our file contents to the file system. So we need a try-catch statement in this case. So we set that up, and we call our I/O manager's writeTextFile method that we just created. And we pass to it, first of all, the file reference, and secondly, the contents. Now we get the contents from the doc again. See how useful this object becomes? It represents everything about our existing document, where it came from in the file system, as well as its existing contents, as well as its name, etc. So in this case, we're calling the getContents method on our doc object. And after this line is executed, you can imagine that the file will now either be created under the specified name on the file system at a particular location, or it will be updated or refreshed with the changes that the user has made within the document editor. All right. Now in the event that it may be a new file altogether, we'd like to maintain that document object. And as you can recall earlier, if it was a new file, the file reference itself was null. But in this case, now that it's written out to a file system at a particular location, it's no longer null. So we need to update our document model itself with the new location of its actual file that has just been created. So we're going to call the setFileRef method and pass to it F. Now this is going to be done in either case. It wouldn't harm the other scenario where it's already there, because it's going to be the same file reference with the same information anyway. But for new files that have just been saved, this will be very useful just in the event that they save again sometime later. They'll be treated as an existing file in the file system. All right. So once we do that, we need to update the TextArea components text document. And we also keep in mind that the file may have changed its name, most likely from Untitled.txt to whatever name you gave it .txt. In this particular case, we need to make some changes. and the changes that we'll make after we update the document, or at least set that particular document to the TextArea component, all right, which basically represents the new refreshed document that has now been saved to the file system. It basically refreshes the instance of the document in the active tab, for instance. After we do that, we call our utility setActiveTabTitle method, which will in turn reflect and refresh the title of our tab to reflect the actual title of our document that we gave it when we saved it in that scenario whereby it was a brand new document. Okay? And to do that, we just for convenience sake, we reference the document again, but we call its getFileName method, which by then should be automatically initialized to the file name that we gave the new file. All right, if you can recall the method inside of the document class. And once this line is actually executed, you can imagine the name of the tab will dynamically change to the name that you gave it initially when saving the file. Once you make these changes, then the last bits would be to link this particular method, handleSaveTextDocument, into our UI. And we're going to link it to the save options, both in our toolbar as well as our file system. To do that, we need to add a listener. We need to register a new listener. So I'd like you to find a line where you have the J menu item, save menu item, and just after we set this accelerator, I'd like you to add this line of code to add the action listener. And we're going to use the same editor listener instance because that's our common class which interprets all of the events and triggers their respective handle XXX methods in our controller. We need to do this up here in the menu system as well as down below where we have our toolbar. So scroll all the way down to find this particular line where we have save button. All right, and we're going to add just after we set the tooltip text to save document, we're going to add the same line but with the save button reference. Okay, so we've added action listeners to both save buttons, both in our menu system as well as our toolbar. The next step is to go to our editor listener down below, our text editor event listener, and add the case that caters to saving. So we first do it in the instance whereby it's a menu item. So just after open, we can add these lines here: save, case save. We call our controller method handleSaveTextDocument, and we break. Okay, and we do the same thing down below when we're dealing with the toolbar events, and we add these three lines as well. You'll notice that we need to make sure that this code here, the text here, coincides with the toolbar text, because this is the only way that we're able to distinguish among the various toolbar buttons and trigger the correct event. Once we've added these lines in place, all of our modifications should be complete. I'd recommend that you fix all your imports and test out your new text editor that's able to now open, edit, and save text documents.